Hey guys, we are going to do a little bit of a review before we start jumping into some new material this year. So today we're going to review polynomials, which you learned about last year. So first I just want to kind of go over some vocabulary that you should hopefully know. And hopefully if you need it, this is just a good reminder before we start learning new things about polynomials this year. So I have this list of vocab here. Words to know. The first one is closure. We don't talk about closure too much. You will see it pop up on the ACT and things like that, but for the most part you won't use it too much. But really what closure means is that if a system is closed or shows closure, that means that if you use a certain operation like addition, subtraction, multiplication, whatever you start with is what you get back. So for polynomials to have closure, what that means is if I take a polynomial and I add another polynomial to it, is my answer still a polynomial, which it is. So that we would say polynomials are closed under addition. So polynomials, they are closed under addition, subtraction, and multiplication. I'll just kind of put the symbols here, but not division. So we will actually look at what it means to divide with polynomials in one of our later units coming up. So just know that for polynomials, they're closed under addition, subtraction, and multiplication. And I have seen that on the ACT before where they ask that question. So it might just be a nice fact to remember for that. Okay, coefficient, that's going to be the number that is in front of a variable. So like if I have 2x, the coefficient is the 2. Just that number in the front. A constant term is going to be a number whose value does not change. So if I have an expression, let's say I have x plus 5, the x can change because I can put any number into it, but the 5 is constant. So that's why we call it a constant term. Okay, degree of a one variable polynomial, so that means it just is like using just x's, is going to be the greatest exponent of the variable in the polynomial. So for example, let's say I have x to the 4th plus 3x cubed plus x squared plus 6, and that's my polynomial. The degree is going to be the highest degree on your exponents, so that would mean it's a degree equals 4. Okay, descending order. We like to write our polynomials in descending order. So just like it sounds, to descend means to go down. So you're going to look at the power of your variables, and the largest power is going to go first. So like in this polynomial I just wrote up here, it's already in descending order, where my exponents are going 4, 3, 2, and then I didn't have any more. So constants, you can think of them as being like a exponent of a 0. There's not even an exponent there, so they're always going to go in the last spot. So constants come last. So we will be writing our polynomials in descending order a lot. Okay, an exponential expression is going to be something that contains a base raised to a power or exponent. So example, you can have a number be a base, so like 2 to the power of x. That's a type of an exponential expression. Another common one you'll see is e to the power of x, and e is a number, kind of like pi. We'll talk more about exponentials later this year too. Okay, a factor is one of 2 or more numbers that when you multiply them produce a given product. So I'll just pick an easy one. If I do 2 times 3, that equals 6. 2 and 3 would be considered the factors of 6. So, and we could list other factors like 1 and 6 equals 6. So those could also be factors. Okay, a leading coefficient is literally just what it sounds like. It's going to be the coefficient that is leading the way, is what I say. So it's going to be the coefficient on the term of your highest power. So if I look at this polynomial from up above, this was my highest power, and so the leading coefficient would be the number in the front, which it's not written, but it would be a 1. So that leading coefficient would be a 1 for that polynomial. Okay, like terms, this might be a good review. Like terms are terms that have the same variable and the same power. So like x squared and x cubed, they are not the same. So they have to have the same variable and same exponent. So when you're looking for those like terms, make sure you're looking for both of those things. Okay, and then a polynomial is just an expression that contains variables, numeric quantities, or both, where variables are raised to integer powers greater than or equal to 0. So kind of just a fancy explanation there. And then a polynomial function is literally the exact same thing, but you're just going to have the f of x in front of it. Okay. And then a term is going to be a number, a variable, or a product of a number and a variable. So a number would be like a 2. A variable could be an x. Or when it says a product of the two, that could be like a 3x. The number and the x are being multiplied. So that would also be considered a term. So let's just kind of practice looking at using this vocabulary a little bit. So it says identify the terms in the expression. What is the highest power of the variable? It looks like my expression got cut off. So let me find that really quick. Hey, sorry about that. For some reason, my printer didn't pick up the polynomial that was right there. So if you printed off your notes and that happened too, these are the examples that should be typed there. But so for example number 1, it says identify the terms in this expression, and then what is the highest power of the variable. So again, terms are going to be either numbers, variables, or some combination of them. And a good way to tell them apart is they are going to be separated by addition and subtraction. So you can almost just put like lines going down. Here's a term, here's a term, here's a term. So there's 3 terms in this one. We would call it a trinomial since there's 3 terms. And then it also asks what's the highest power. So this power would be a 1, just you usually don't write them. And then this power is a 2, which is the highest. So the highest power is going to be a 2. So pretty straightforward there. Hey, identify the terms in this expression. So again, this is what should have been typed there. We have negative 2x to the power of 8 plus 3x squared minus x plus 18. So again, they're going to be separated by those addition and subtractions. So you have 1 term, 2 term, 3 term, 4 terms. And then it says note the coefficient, variable, and power of each. So coefficient on this one, we do want to take the negative with it. It would be a negative 2. The variable is an x, and the power is an 8. So I'm just going to kind of write it below each one. The coefficient on this one is a 3. The variable is still an x, and the power is a 2. The coefficient on this third term, remember if it's not written, it's like there's a 1 in front, but we'd want to bring that negative with it. So it'd be negative 1 for the coefficient. The variable is an x, and then again, if there's not a power written, we also write it as just a power of 1. We're usually just lazy and don't want to write our 1s a lot, so. And then for our last one, because it is just a constant, that kind of counts as the coefficient, and then there is no variable and there is no power, so it's kind of its own little thing. So kind of a little overview on all those different terms that we've been using. Okay, and then this one also didn't print with very much space, but it says write the polynomial function in descending order containing these terms. So it says negative x, we have a 10x to the power of 5, a 4x to the power of 3, and then a negative x to the power of 7. So if I'm putting in descending order, remember that goes by the degrees. So our highest degree is a 7. A common mistake I would see on this one is people would see that it's a negative and want to think that that means it's smaller, but the negative isn't applying to the power. We're just looking at the power. Another thing that I see kids make mistakes with is they look at the coefficients and they say, oh, 10, that's the biggest number. That one's going to go first. But again, we're just looking at the power. So this is a 5, a 3 is 7, and this would be a 1 if we wrote it. So don't look at the coefficients or the signs, just the powers. So 7's the highest, so that one's going to come first. And then I'm just going to go down from biggest to smallest. So the next biggest would be the power of 5. So we have a 10x to the 5th. Since it's positive, we're going to put a plus there. And then we just keep going down. So the next power would be the 4x cubed, which is also positive, so we're going to add it. And then our last one would be the negative x to the power of 1, which we don't really need that power of 1, so I'm going to leave it off. And that would be your descending order right there. And then they also said determine the degree of the polynomial. So remember that degree is also going to be that highest power. So that degree is a 7. So this polynomial has 4 terms. This is in descending order, and its degree is a 7. Okay. And then now that we've kind of gone over all those vocab terms, I just want to go over some of the operations that you see with polynomials quite a bit. So this should again be a review from last year. Hopefully it seems familiar, but we're going to look at what happens if you add polynomials, subtract them, and then we're going to multiply some as well. So starting off with adding, sometimes they'll have parentheses around them, but they don't always have to. So the parentheses really are just a grouping thing. They're just saying here's your first polynomial and your second. Other than that, they don't really do anything in our addition. So what we're going to do is look for our like terms. Remember, to be a like term has to be the same variable with the same exponent. So I've seen different methods for this. Some people can do it in their head. If that's you, great, go for it. If you have a harder time seeing the like terms, one strategy that you can use is to put different shapes around the same kind of term. So like if this is an a to the fourth, I could put a square around it, and then I'll put a square around anything else that's an a to the fourth, but I don't have one, so that's the only one. This one is just an a, which would be a power of 1, so maybe I'll put circles around this. So that one has a different degree. This one is an a with the power of 1, so I'll put a circle around it, and then that's power of 3 and a power of 2. This one's a cube, so maybe I'll put like a triangle around it. Same with this one. And then we have a squared. Could put just maybe an oval. I'm running out of shapes. So that's a way you can use it if you are a visual person, and it helps you to kind of see that grouping. Most people, though, after they've done it so much, can just start doing it in their head. But I do like to go in descending order, so I like to pick the highest degree first. So that's our 7a to the fourth. But since there are no other 7a to the fourths, I don't have anything to add, so it's just going to come down. And I'm going to just cross it out so that I know that I've used it and I don't forget any pieces. The next degree, if I'm descending, would be the 3. So I'm going to take my a cubes. I have one here and one here. So I'm starting with a plus 8a cubed, and now I'm subtracting, that was a negative, an a to the cube. So 8 minus 1 is 7. So we get 7a to the cubed when I combine those two, and I'll cross them out. The next degree, if I'm descending, would be a power of 2. That's power of 1 and power of 1, so this is our only power of 2. So since it's by itself, we don't have to combine it. Don't forget that this was a minus in front, so we want to bring that negative with us. So that negative 4a squared is just going to stay the same, and we'll cross it off. So that leaves the last two pieces are both just a's. So we're going to combine those since they're the same type of term. I have a negative 1a, and I'm adding to it 3a's. So negative 1 plus 3 is 2. So we have a 2a. And I like to do it in that order because then I'm already in descending form when I have my answer, and I don't have to go and do another step and rearrange it to get it into descending order. I'm just good to go. Okay, let's look at subtraction. With subtraction ones, you do need to be careful with the signs because this minus is saying I'm subtracting everything inside of here. So a common mistake that I see is people will say I'm just minusing the 8n, and then they don't do anything to these signs right here. But really, we need to take this negative and distribute it in to all three. So that means I'm subtracting this 8n, but then when I subtract a negative, it turns to a positive 8. And then when I subtract this 4n cubed, we're going to get a minus 4n cubed. So that minus here is going to switch the signs of all three of these things. And then we have our 5n squared plus 5 plus n cubed. And then because we're already minusing it, we don't need to worry about our other signs there. So I'm not going to do the shape thing that we did up here. I'm just going to start doing it in my head. Hopefully that's okay. But again, you can do this little shape trick if that is a good visual for you. So I like to pick the highest degree. So if I scan through, my highest degree, it looks like is a 3. So I'm going to combine our cubes here. I have 1n cubed and I'm minusing 4n cubes. So 1 subtract 4 is going to be a negative 3n cubed. And I still do like to cross them out so that I don't accidentally forget anything. So I'm going to go one step down. So let's do our degree 2's now. I have a 5n squared, but looking through, there's no other n squareds. So this 5n squared is just going to stay a 5n squared. And since it was positive, we're going to add it. The next degree would just be an n, or an n to the power of 1. But same thing, there's no other n's to compare or combine. So we're going to just keep that as a minus 8n. Then our last step are just our constant terms. We have a 5 plus an 8. So 5 plus 8 is 13. And again, we're just already in descending order if we do it while we are combining our like terms. So that's the nice thing with that. Okay, hopefully that's a good review on adding and subtracting. Now with multiplying, that's going to be our next 3 problems. I have different types where you have either a monomial, which means 1 term, going into a binomial, which is 2 terms. This is a binomial, 2 terms, times another binomial, 2 terms. And then on this last one, I have a trinomial, 3 terms, times a binomial, 2 terms. So this one's obviously going to be the easiest one because it's the smallest. We're just going to use our distributive property, kind of like how we distributed the negative up here. We're going to distribute the 7x squared through. So I like to draw the little like rainbow shape to help me. But we're going to do 7x squared. And I'm going to write out this step, even though a lot of people can do it in their head. So I have 7x squared times 8x. Well, 7 times 8 is 56. And then x squared times x. Again, think of this as a power of 1. Whenever you times variables, you're going to add their exponents together. So 2 plus 1 is 3. So we get an x cubed. And then we're going to do the second rainbow. So I'm going to do 7x squared times 5. This one's a little bit easier because we just have a number. So we're just going to times the 2 numbers. 7 times 5 is 35. And then keep the x squared. And it's already in descending order. We have our 3 going down to a 2, so we're good. So those monomials timesing into a binomial, they're not too bad. Okay, part D, we have a binomial times a binomial. There's a couple different ways that you can do this depending on how your teacher taught it. I like to do the FOIL method. I'm going to do that one first, and then I'll also show you how to do box method if that's something you like to do. But FOIL, we're essentially going to be doing the distributive property, but 4 times. So first I'm going to distribute this 2a into both of these, the 5a and the 5. But I'm also going to distribute the 8 into the 5a and the 5. So we get kind of the little rainbows on top and bottom. So I'm not going to write this step out again this time. I'm just going to do it in my head as we go. But we're going to do 2a times 5a. 2 times 5 is 10, and a times a is a squared. Then 2a times negative 5 is a negative 10a. And then 8 times 5a, well, 8 times 5 is 40, so we're going to get 40a. And then 8 times negative 5 is a negative 40. And so then once you get to this step, just check to make sure you have it simplified. A lot of times you're going to have like terms that you can combine, which in this case we do. We have those a's there. So if I have negative 10a and I'm adding 40a to it, that's going to leave me with 30a. So I have 10a squared plus 30a minus 40, and that would be my answer. And then just kind of a reminder, if you did learn the FOIL method, the reason we call it FOIL is it's just an abbreviation. The F stands from first times first, so you're timesing the first term in each group, first times first. The O stands for outside, so these are your outside terms, so we times those together. I stands for inside, so the 8 and the 5a are the inside terms, and then the L stands for last times last. So that's where the FOIL comes from. The other method that's really popular is the box method, so I'll show that to you really quick. It's just what it sounds. You're going to draw a box, and then depending on how many terms you have is how many rows and columns you have. So I'm going to do a 2 by 2 box since we have 2 binomials. So 2 columns, 2 rows. And then it doesn't matter which one you put on the side or which one on top. You just need to keep them together. So I'm going to do the 2a and the 8 down the side, and then the 5a and the negative 5 on the top. And make sure you bring the negative with if you have one. So that negative needs to be with that negative 5. And then this is just a really good way to kind of organize it. So if you're a visual person, you might really like the box method, but you're just going to do the top and then do your row and your column together. So I'm going to do 5a times 2a goes in this box. Well, 5 times 2 is 10, and a times a is a squared. Now we're going to do this column times this row. So 5a times 8 is 40a. Now let's move over to this column. So negative 5 times 2a is a negative 10a. And then negative 5 times 8 is negative 40. And you'll see these are all the same terms we have written out here. So again, it's just more of a visual way to organize it. If you're a visual person, you might like that method more. But then once you get to here, we're just going to combine any like terms. So we do see again that we have those a's that we can combine. And then I'm going to put it in descending order. So the a squares are going to go. Sorry, my phone was telling me my battery is low, so it cut me off. So we left off with the same. We're going to do descending order, so that a squared is going to go first. Then we're going to do the a's, which we can combine. So 40 a's minus 10 a's is 30 a's. And then we have our negative 40 in the back. So same answer for the same problem. So you really can pick. If you prefer foiling, go for it. I do think this method, once you get good at it, is faster than having to like draw the box. But if you like to be organized and this is, resonates with you, go for it. You can do the box method. I do like the box method more when doing problems like this that are bigger, because it can get really messy when you're foiling with a big one. So the box method will keep ones like this a little bit more organized. So when they're bigger ones, I do prefer the box method. So let's do this one the box style. Since I have a trinomial and a binomial, we want a 3x2 box. So I'm going to do 3 columns and then 2 rows. And again, you could flip it. You could do 3 down and 2 across. It doesn't matter. But I'm going to put the trinomial along the top, 4k squared minus 4k minus 2. Again, bring those negatives with. And then I'm going to do the k minus 5 going down. K minus 5. And then we'll just repeat it. So 4k squared times k is 4k cubed. 4k squared times negative 5 is going to be a negative 20k squared. Negative 4k times k is a negative 4k squared. Negative 4k times negative 5, those two negatives are going to turn to a positive 20k. Move to the next column. Negative 2 times k is negative 2k. Negative 2 times negative 5 will turn to a positive 10. So again, this way you have all of your terms just organized really neatly. You're not going to be foiling over and over. But we're just going to go descending again. So cubes, that's our biggest degree. So we're going to do our 4k to the 3rd power first. And then we do have some like terms again. And you'll notice during the box method, they usually go on the diagonal like that most of the time. Not always, but a lot of the times they will follow that diagonal. So both of these are k squareds. So I'm going to combine them. I have negative 20 and then a negative 4. So that's going to give me a negative 24k squared. And then again on our diagonal, we have just the k's. I have 20k's minus 2. So that's going to be 18k's. And then we have our constant term plus 10. So I do think the box method is a really good way to do the bigger multiplication problems just because it keeps it organized. You definitely can FOIL it still, but you're just going to get a lot of rainbows because you're going to be drawing all of those. You can still do it though, it just gets kind of messy. So feel free again to choose either FOIL or box. I just like the box ones more when it comes to multiplying with trinomials. But that is our polynomial review. We're again going to jump into some new polynomial stuff coming up, so we want to make sure everyone feels good about this stuff before moving on. So please, I'm going to write it really big, please, please, please email me if you need help on any of this. We can also do like a Zoom or a Google Meet, and we can talk face to face. Well, I guess not face to face, computer to computer. And I can help you and kind of tutor you one-on-one if you want extra help with any of this material. So hopefully that was a good review. Go ahead and get started on your first assignment in Canvas. Just 1.1 assignment on there. And let me know if you have any questions. Hope you guys have a great day. See ya.